Now, hand in hand with solubility is the idea of conductivity. You've heard of the term electrolyte, right? Like you drink Gatorade. Electrolyte is a substance that when you put it in water, it conducts electricity. So if we were to conduct an experiment where we take ionic compounds and we put them in water and we stir, and then we check to see if it conducts electricity. This here is a picture of a conductivity tester, and this is clearly a situation where you're putting it in something and it is conducting the electricity because the light bulb is going off. If you were to put it in something and the light bulb does this, then it clearly does not conduct electricity. Now, before we get into the specifics, let's take a look at the obvious difference between these two beakers. What do you notice about that beaker? And then what do you notice about that beaker in comparison? Think back to our last lesson on solubility. What does that look like? And then what does that look like? Now then, let's take a look. Here are those same 12 substances. All of these substances here conduct electricity. All of these substances here do not conduct electricity. They're the same 12 substances. Hey, look at that pattern. Check it out. All of these guys here, -1, +1, -1, +1. Sorry, excuse me. +1 and -1 here. All of those guys, they all have +1, -1. They're all weak. When they're all put into water, they're all ripped apart, and those ions are free to move, and that's conducting electricity. These guys here, they're all strong. There's no +1s or -1s here, so none of these guys get ripped apart. None of those guys are going to conduct electricity. So again, the idea of conducting electricity is the movement of charge. That's what electricity is. So like when you go up to a piece of metal after you've been in the, scuffling around on the carpeting in the middle of winter, you get static electricity. You don't even know you have that electricity on you until you touch it, and the zap is the movement of the electricity. So again, this guy here is the movement of the electrons, right? So if we were to take a look at these crystals, the crystals here all have positive and negative charges, but in the solid form like this, they can't move, so it doesn't conduct electricity. So we check that out. So that salt, it doesn't conduct electricity because even though it has positive and negative charges in it, they can't move. And again, for electricity to happen, you got to have movement of charge. So here is deionized water. It does nothing. Here is, again, salt that is not in water. It has charges, but it can't move. Here is salt in water. The salt has been ripped apart, and now that the salt has been ripped apart, those ions can move, and when they move, that's the conduction of electricity. So it's very, very easy. Ionic compounds that are soluble dissolve, are ripped apart, the ions can move, they conduct electricity. Ionic compounds like this one that are cloudy do not get ripped apart. The ions are there, but they're locked together and they can't move, and if they can't move, they don't conduct electricity. So this here is insoluble, it's cloudy, and it doesn't conduct. All right? Something like this is soluble, it's clear, right, which is why it dissolved, and it does conduct. So for ionic compounds, the rule is the same. If you have a +1 or a -1 compound, charge in your compound, it's probably going to be soluble, and it's probably going to dissolve, and it's probably going to conduct electricity. So again, you're talking about +1 or -1 or both in there. Probably. If it's like this, insoluble, cloudy, or doesn't conduct, it probably does not have a +1 or a -1 in it. Probably. Generally.